And
I do have to. Oh,
go ahead. You have to go at a certain time?
I have to leave at like 8:15ish. So because I
We
have
could
to
go
eat
15
dinner.
minutes over, is what you're saying?
Yeah.
Okay. All right. Okay. Okay, so it's my opinion that every single person should make the unit circle at least once in their life. Okay, so let's talk over a few things. So a unit circle is just a circle with a radius of 1. So let's identify some things here. So what is my radius here?
1.
Good job. Okay, so that's just like, you know, this distance or this distance, right? Radius. Okay.
Mm-hmm.
My diameter is then what? There's going to be 2 radiuses and a diameter.
2?
That's correct. So here, like this is the diameter right here. This is the diameter. This could be the diameter if I if I actually drew it straight. Those are all diameters. Okay, like a radius is a spoke of a wheel. Diameter would be like 2 spokes. Okay.
Mm-hmm.
So the circumference is going to be the diameter times what? What do we multiply the diameter times to get the circumference?
3.14 pi.
Yep, that's exactly right. So the circumference is going to be 2 times 3.14 or 2 times pi. So we'll say 2 pi. Well, we should probably say approximately 6.28. And that means if I were to take this distance right here, let's say I would take a string and I were to lay it all around, I would get 3.14 of that. And I've done it before, actually. I was teaching someone it completely from scratch. We took some yarn and we went around and there was 3.14 diameters around the circle. Okay, this is always going to be true with any circle. Okay. All right, so let's come up with some points here. So we're going to call this guy right here 0, 0. This, oh, they already did it for us. This is 1, 0. Right here. So what is this point right here?
4.
It's actually
0.
just 1. It's just 0, 1.
Oh, that's 1. Oops. Well,
yeah, no worries.
0.1.
I think you were counting from this way or something.
Yeah.
Okay. So this point right here is going to be what?
1, 0.
Negative 1, 0.
Oh yeah.
Yeah, sometimes I mix these up too. I'll be like, I'll go the whole time and something will be like
The other side is
yeah,
1,
the other
0.
side.
And then this is negative. No, 0, negative 1.
0, negative 1. Okay, so the unit circle, meaning we have a radius that is 1 unit or just, you know, 1 unit is the same thing as like one thing. That's what a unit is. Okay.
Mm-hmm.
All right. So I know you were asking about the circle, the equation of the circle. So this is what it is. Okay. It's going to be x minus h squared plus y minus k squared is equal to radius squared. In this case right here, okay, our point of center is 0, 0. So it's going to be x minus 0 squared plus y minus 0 squared equal to radius squared. So this is really x squared plus y squared is equal to radius squared. I know radius squared is 1 squared, but just hang out for a second. We'll just leave it this. Does this look familiar to you in any way? X squared
Yeah,
plus y
it's.
squared.
Mm-hmm.
What does it look like?
It kind of looks like it's like an equation of something.
It's an equation of something else. That's right. I'm gonna see
Yeah.
if I can jog your memory. Imagine if I were to do this. Okay. Let's say I were to
That's
draw
a
a right
triangle.
triangle. Let's say this was the radius, right? That's
The
radius.
3, 4, 5.
It is a 3, 4, 5 triangle. Well, that may not be, but the 3, 4 triangle is an example of what kind of triplet? You're right.
Triplet.
Pythagorean triplet.
Oh yeah, the Pythagorean theorem.
Okay. So let's say this point right here is going to be some x and this is going to be some y, right?
Yeah.
Okay. Isn't this x and this y?
Yeah.
Okay. It's the Pythagorean theorem. The equation of the circle is just the Pythagorean theorem, but instead of a and b, we have binomials. So that is how you memorize the equation of the circle. just think, oh, it's just the Pythagorean theorem, but instead of A and B, I've got X minus H, Y minus K.
Mm,
And suddenly
okay.
it becomes a lot easier.
It does become a lot easier,
Mhm. Okay. So this is X squared plus Y squared is equal to 1 squared, right?
yeah. Mm-hmm.
Okay, but you know what? There's right there. See, remember I told you I'd come back to that? There it is. See? Every step of the way, I got you. Okay. See that?
Yep.
Okay. So, do you want you to take a screenshot eventually? So let's do, I wonder if I can, I'm just going to draw this right here. So X minus H squared plus Y minus K squared is equal to radius squared. Okay, there's your equation. Okay, do I need
Got
to make, I need to make it a little neater, don't I?
I mean, I can still read it. So.
Okay. Okay. X minus H squared. Okay, so there's your equation of the circle. Okay,
Got it.
great. I'm moving the little thing around. Okay. All right. Okay, so what does this have to do with trigonometry? Well, the trigonometry has everything to do with the Pythagorean theorem, right?
Mm-hmm.
So remember before when we did the 30, 60, 90 triangle? It was a few weeks ago, but you know, the 30, 60, 90 triangle
Yeah.
is just the half of the equilateral triangle, right?
Yes.
Okay, so then when we did it before, we worked out, well, this is not necessarily a perfect equilateral triangle, but we ended up with this, right?
Mm-hmm.
Okay, and then we can go ahead and get rid of this part right here. We figured out these two sides. We know that this is 60, and then we have this right here, so this is 30. And then we worked it out, right? So we did the Pythagorean theorem to do c squared minus b squared, c squared minus b squared equals a squared, or, you know, a. So we did 1 squared minus 1/2 squared is equal to a squared. So 1 minus 1/4 is equal to a squared. 3/4 is equal to a squared. Take the square root. This ends up being the square root of 3 divided by 2 is a, right? Or if you're going to stick that in your calculator, it's a square root of 0.75, right? Is equal to 0.866 is equal to a, right? Do you remember doing this with me?
Yes.
Okay.
Mm-hmm.
Now, okay, so 0.86, or in other words, the square root of 3/2, right? Now I'm going to draw, now I know that the equilateral triangle has a side of 1. I know that any radius is 1, right? Any single radius. I'm going to actually have it hit at 1/2 right here. See that?
Yeah.
Okay. I may not be drawing this perfectly, but I'm going to do my best, okay? And I'm going to have, so, well, okay, so let's try this again. Then because I know that this is 1/2, can't I just assume that this is the 30, 60, 90 triangle? This is 1/2, right?
Yeah.
Okay. Now, if you were to like look at this, does this check out like a gut check at 0.866? Does that gut check that?
Yeah, a little
It
bit. Yeah.
does. Okay. It does. All right. All right. So this right here, this point right here is going to be 0.866 and 1/2, isn't it? Or 0.5, isn't it?
Mm-hmm.
Okay. Now, I'm going to be honest with you. That's not how we write it in trigonometry. We write √3/2, 1/2. But I think it's really important.
Isn't that the same thing?
Yes. Okay.
It's the same thing.
Now watch this. Okay. It is the same thing. You are right. Okay. Okay. I don't want to mess this up. So I want to stop. Okay. There we go. Now, Desmos is a lot of fun. Watch this. Wait, hold on. I gotta. A second, if I can remember the thing that's supposed to happen here. Okay. Oh yeah, there we go.
Oh, that's for the circle. Yeah.
Okay,
It's the
so
points.
yeah, so this is all of the right triangles we could potentially do, right? Oh no, I didn't mean, okay, there we go. But okay, so now I'm going to go ahead, instead of having it do this, I'm just going to do 60 degrees. Hopefully it lines up to what we just did. Oh no, I'm sorry, 30 degrees. Sure,
Close enough.
close enough. Okay. And look, 0.866, 0.5. See that?
Yeah.
There it is. Okay. That's just the Pythagorean theorem, isn't it?
Yeah.
Okay. So then when we do the unit circle, we will write √3/2 and 1/2. Okay.
Yeah.
All right. Now let's take a look if instead we were to do 60 degrees. Okay.
Oh, it's like the
yeah.
opposite. Or it's like flipped.
That's correct. I'm actually gonna, once we do a line, I'm gonna, there, okay? I'm like, which one is it? Okay, it is. We've just inverted it, right? And remember when we did that, remember the sine of 30 is equal to the cosine of 60? We realized that?
Yeah, SOHCAHTOA.
There you go, okay? So this point right here is going to be 1/2 √3/2. Make sense? Okay.
Yeah.
All right, so I'm going to get rid of this. I'm going to clean this up just a little. I'm going to delete this Pythagorean theorem here just so we can clean this up, okay? Okay. I'm going to draw this meter over here. Okay, so radius equals 1, diameter equals 2, circumference equals 2, height, or in other words, 6.28. Great. Okay, so then we write this point here. Let's see if I can figure this out. So it's going to be sine 60. Yeah, there we go. Okay, see how these lines come? Now, when I'm writing the unit circle, I like to do the other line, like once I draw this line, I like to do this point right here. So now, if this point is √3/2 and 1/2, what is this point right here? Now, I know right now it probably doesn't make any sense to have negative degrees, but just hold your horses on that one, okay? I'll explain that in a second. But we can absolutely figure out what this point is right here, can't we? Okay, so what is it? What's it going to be?
Would it be negative 1/2?
On the y, it's negative 1/2 on the y.
Oh, it's negative 3/2.
That's correct. Good job. Well, √3/2.
√3/2. Yeah.
And this one right here is going to be negative 1/2 negative √3/2. See how that works? When you can literally see it. See? Now I wish I could, you know what? I'm just going to do something real fast. Let's just do this. Just to make it a little easier as we just make this thing. Okay. Okay. Well, is that helpful?
Yeah.
Okay.
It's the decimal form of √3/2. Yeah.
Exactly. Okay. Oops, I did a little extra negative there, didn't I?
Yeah.
Okay, we'll erase that when it's done, but I just think that like it gives a little framework. We call it, I used to work for the Department of Transportation when we would like build things. We call that scaffolding. We call it false work. It's just like to help us frame things. So sometimes I use the same word. Now let's put the false work up for now. And then we'll take it down. It's not false. It's just kind of scaffolding, if you will.
It's to visualize it, right?
Yeah,
basically.
Exactly. All right. Okay, so now let's move on. So imagine when we were to, now we want to figure out what this guy is right here. Okay, so this guy right here is going to be, yes, I did it. Oh, wow, I did that right on, didn't I? Okay. All right, so what point is this going to be?
Negative, no, right?
One of them's negative. It is.
It's negative 1/2.
Yes.
Okay. And then it's the cube, the root 3/2. Yeah.
Good job. And you said it right too.
I almost said cube root, but
Oh, that's funny, right? So
I
cube root is
caught
not the
myself
square root of
though,
3,
so
but
it's
a
good.
lot of people mix this up. So good job in catching yourself. Seriously, good job. So it's negative root 3/2. Okay. Now let's go ahead and just do this, guy, since we're at it, right? Might as well make our jobs easier on us. This is going to be positive what?
Oh, 1/2
Yes, and good job. Negative.
root 3/2.
Right.
Negative root 3/2.
Good job. Okay, so now let's check it. See if I can stop it. Oh, no. Okay. This is actually 120 degrees. And I know, again, that's kind of a weird concept, but just when we do circles, we actually measure this guy, even though we're working with this triangle right here. It's kind of weird, but I'll explain it in a second, okay? So you're like, what? 120 degrees doesn't belong in a triangle? I know. In math, we call it expanding the definition. It's just like mathematicians like to go, well, here's the rules. Let's push them a little bit further. What if we did this? Okay, so what if we did say at 120 degrees instead of 60 degrees, right? That's kind of what's happening. But also,
Okay.
we do a lot of angles that aren't just, the reason we do this is we need trigonometry. Angles helped us build trigonometry, but we really need to measure arcs most of the time. Most of the time, people practically use trigonometry for arcs. So this is just a framework. Does that make sense?
Yeah, it
Okay.
does.
Oh, wait, actually, I made a mistake. It's positive root 3/2.
Ah, so I was right.
You were right. Okay. All right. So we did this one over here. So let's go on to the next one. So it's going to be approximately right here, right? But let's have this thing measure it exactly for us. So this is going to be 150. I'm just adding 30 degrees each time. Oh, I was off. So this is going to be negative what?
Negative root 3/2, and then the 1/2.
Great. Okay, and then we're going to go ahead and draw our little line here. It's going to be 150, sine of 150. Okay. All right, so then we're going to do this point over here. This is going to be positive root 3/2, negative 1/2.
Okay.
And we have filled out all of the different ways we can think about the 30, 60, 90 triangle. Basically, it's gone every which way, right?
Yeah.
Different ways it could go around. Okay. Usually when now the unit circle can really be meant to really just be used for all of the triangles. Really, we could do, 15 degrees, right? But normally they only do the 30, 60, 90, and then all the other, like, I forgot what the word is, where they just kind of keep going, and the 45s. Okay. So let's do that one. So if we just real quick, quick little review. If I press stop share, then they'll all go away. Let's think about the 45, 45, 90 triangle, which of course is just, half of a square, right? Let's go the other way. Okay, so I don't know why. Actually, I don't want to go that way. I want to go this way. I don't know why I did that. Okay, this way. You want to go this way. Okay. 45 degrees. 45 degrees. We want our radius to be 1. So then we're going to do the Pythagorean theorem, which is a squared plus b squared. But this is an isosceles triangle. So it's really a squared plus a squared, right? So we're going to do a squared plus a squared is equal to 1 squared. 2a squared is equal to 1, divides both sides by 2. A squared is equal to 1/2.
Yeah.
Okay, so then we're
It's
gonna
the same thing for the circle formula. So that's where it connects. You said it before, so
that's right. The circle formula is the Pythagorean theorem. And in this case, they're equal to each other. Exactly. I told you, like once you build this unit circle, it's like, oh, it just happens over and over again. Okay, so A is equal to the square root of 1/2, or in other words, 0.7. But honestly, they don't let us say the square root of 1/2 because it's equal to 1, the square root of 1 or the square root of 2, and they don't like it when you have radicals on the denominator. So this becomes 1 over the square root of 2. You multiply this by root 2 over root 2, because that's the same as multiplying by 1. This becomes the square root of 2 over 2. Okay, so I wished we could say the square root of 1/2, because that makes sense as far as the Pythagorean theorem goes, because it's like, well, whatever this is an isosceles triangle, so whatever the hypotenuse squared is, we're going to half that and take the square root of it, square root of 1/2. But they don't let us say that. They didn't ask me when they made the rules for algebra and trigonometry. So we say the square root of 2 over 2, but it's the same thing as square root of 1/2. Okay.
okay.
Now it's also approximately 0.7. Now let's go ahead and just clean this up. We have room. Let's see if it's approximately, oh, that is, let's see if it's approximately 0.7. Let's see if that works out. Yeah, it really looks like it, right? If I were to draw this right here.
It's
Okay.
close to 0.7, yeah.
0.7, that's correct. Okay. So this is theta is 45 degrees, 0.707 and 0.707. Okay. Now, of course, we write this point as the square root of 2 over 2 root 2 over 2. Now, all of these okay. And then we can do these guys. It just here's the thing about the unit circle. Once you know how it works, and once you fill out the first sector, the first quadrant, everything else kind of falls into place.
It makes it easier, I guess.
That's the unit circle. We're not quite done with it, but that is the essence of the unit circle. So again, we can just watch it go around, and you can see how the circle is intrinsically related to the Pythagorean theorem. This really drives that home, doesn't it?
Yeah, it does. It makes it also like a lot easier. So this is really good. Yeah.
Now, I've actually hoped, I think there's something like 2 blue, 1 brown could possibly do this, but I would really like to have this and have like squares come off of this to really show it. But I've been able to work out at least this much. I was able to program that. Actually, my son had to help me. As you can see, this is the Pythagorean theorem. See? Side squared plus side squared is equal to hypotenuse squared. See it?
Okay. Yeah, I see it.
All right. But this one right here, it took me a while to figure out, honestly. The absolute value. I was like, and then I was like, okay. Oh no.
That does look really difficult.
Oh, look what I did. I messed it up.
No, I think you're close.
Okay,
you're close.
okay.
I just line up the 0 zeros.
Oh no. I'm not sure. Okay. Oh, there we go. Okay. Okay. So great. Now, okay, let's see how much time do we have? We have plenty of time. We're doing great on time. Okay. Let's say you throw a party and you're like, I'm so glad that COVID is over and no more masks, all this stuff. So you throw a pizza party and you invite 12 people. Okay. No, 11 people. So it's 12 people, including you. And you order from this place and they're called the Pizza Pie. Okay. And they spell it P-I because, you know, they're math nerds.
Oh, it's pie, yeah.
Yeah. Get it? Okay. The Pizza Pie. Okay. So their whole deal, their whole shtick is two things. One, they have an amazing crust. It's the most delicious crust. They use all this science, like food science, because they're super sciencey, to make most delicious crust. But the other thing they do is they have a laser cutter that exactly cuts. Okay, so if you order 12 slices, you're going to get as perfect as machinery can make it, exactly sized slices. You're going to have 12 slices that are exactly the same. Got it?
Got it.
Okay, so if you order a 2-foot pizza, okay, 2-foot pizza, which means the diameter is 2 feet, and you were to divide it into 12 equal slices, how many degrees will each slice be?
Oh,
In order to remember this, we have to know the degrees of a circle. So the degrees of a circle is what?
2.
It's 2 pi is the radians.
Oh, 2 pi?
Okay, forget what I just said. How many degrees is in a circle?
2. It's right up there. 2.
Oh, that means diameter.
Oh, degrees like 360?
There you go.
Okay.
360 degrees.
Well,
You were like, it's right there. There's a D right there. Okay, so
that's like the most basic thing ever. The degree of a circle is 360. Like always.
5. So this is like we went a different place in your brain, and now we're going back to a thing you already know. It's fine. It happens a lot. Okay, so 360 degrees. Okay, so if you were to take divide that by 12, how many degrees would one slice be?
So you would do 360 divided by 12, right?
Mhm.
Okay, so you'd 30? Yeah,
30
30.
degrees. So really, this would be one slice, right? This guy right here.
One slice, yeah.
Okay, now let's say your friend is like, listen, I don't know what these food science guys are doing, these nerdy people, but this is the best crust I've ever had. And your friend's like, listen, I know this is a weird question, but I want to know exactly how many feet of crust I ate. And you were like, no, I get it. That's not a weird question at all. Okay. And you were like, but I know trigonometry. I know that if this is 30 degrees, the sine of 30 degrees is 1/2. I know that. So I know that if this guy is 1, then this is going to be 1/2 of 1. But that's not what you were asked. Okay. Pizzas don't come in right triangles, do they?
Nope.
They come in sectors. So you were actually asked what this was, weren't you?
Yeah.
Okay, so what are we going to do? Well, we're going to take the circumference or the crust of the entire pizza and divide it by 12. Circumference divided by 12. Or in other words, 2 pi. Well, let's do 6.28. 6.28 divided by 12. Now we know that it's a little bit more than 1/2 a foot. So it's going to be a little bit more than 0.5, isn't it?
I think so, yeah.
Yeah, but we're going to go ahead and just put it into our calculator. I'm going to do 2 pi, 6.28 divided by 12. And I get 0.523.
Yeah, I got
And
the
that
same
tracks, right?
thing.
Right? So instead of this, which is 0.5, we did this, which is 0.523, right? That
So it's an
like,
actual
with our-
pizza slice.
Yeah, okay. Now this is called a radian, okay? Now we usually don't write radians in decimals. We usually leave them in terms of pi. So instead of saying 6.28 divided by 12, we could say 2 pi divided by 12. Just do a little fraction work here, and we get pi over 6.
6.
Okay, now check, you can even do that in your calculator, you can check. And I just did, it is the same number.
Oh, it is. I did too, yeah.
Okay, so we don't write, typically speaking, we don't write radians and decimals. We're usually just going to write them in terms of pi. Now, at least as far as high school goes, okay? So let's do a different color for radians, okay? So this guy
Okay.
right here is going to be pi over 6, okay? Now, if this is pi over 6, what is this guy right here? Now it's going to be double, right?
Okay.
No, this is gonna be a little bit different. It's not like a flip-flop inverter like it has been before. This is literally, now we're gonna have two crusts of pizza. So it's gonna be pi over 6 multiplied by 2. So just tell me
Pi over
what
6.
that
So
would
it would be like, wait,
So let's just work through it. Pi over 6 multiplied by 2, right? This becomes 2 pi over 6, right?
and then yeah.
But I want to reduce this. What could I reduce this by?
3 maybe.
I'm going to reduce it by 2. I'm going to divide the numerators.
Oh yeah, because okay,
Mhm.
yeah.
Yeah, but you're going to end up with pi over 3, right?
Yeah.
Good. Okay. So this is pi over 3. Got it?
Got it.
Now, I think what gets hard about radians is as the radians get bigger, sometimes it looks like they're getting littler, but remember, as the denominator gets smaller, the number actually is bigger, right?
Right.
Right. So just keep that in mind, okay? Now we could go another slice of pizza, get to this one. This is going to be 3 pi divided by 6, or in other words, just pi over 2. Okay. Okay. And then we can keep going. This guy will be 4 pi over 6. Or in other words, 3 pi over 2. I'm sorry. No. I made a mistake. Oh, Kitty. 2 pi over 3.
Oh,
right?
1 sec.
No
One sec.
worries. Kitty break.
Yeah, she just wants to bother me.
Yeah, I can hear her purring. I have to tell my cats all the time, trigonometry is not for cats.
Yeah, she'll learn some math too. Okay.
Okay, so let's go even further. So this is going to be, we're going to know that this is going to be 1, 2, 3, 4, 5. So this is going to be 5 pi over 6. We can't really reduce that one. Right?
Not really, yeah.
Okay, so this one is going to be 6 pi over 6, or in other words, just pi. Okay, the next one is 7 pi over 6. The next one will be 8 pi over 6, or another's got to divide both the numerator and the denominator by 2. I'm going to do 4 pi over 3. Let's write this better. 4 pi over 3. All right, the next one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi over 6, or in other words, am I saying that right? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi over 6, or in other words, just 3 pi over
2. Yeah.
Okay, so this is going to be 10 pi over 6, in other words, 5 pi over 2. This is 11 pi over 6, can't reduce that. This is 12 pi over 6, or in other words, 2 pi. So a full circle is 2 pi, but you know what? You already knew that.
Yep, it's already given to you.
So in other words, we want it, this is the conversion. It's going to be 360 degrees is equal to 2 pi.
And you broke it down to make it more simpler. Because like if you're giving like on the SAT, like what's half of the like circle, and you would need to know this to find it out.
Okay, so now let's go ahead and clean this up. Get rid of the false work. Okay, so now let's do the 45s. Okay, so that's what I call them. So this one right here is going to be 2 pi divided by 8, right?
Yep.
Okay, so the 2 pi divided by 8 is pi over 4. Make sense? It's just fraction work. Once you understand how radians work, it's just fractions, okay? Pi over 4, okay? So 1 pi over 4, 2 pi over 4, 3 pi over 4. So this is 3 pi over 4, right? 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, okay? Make sense?
Makes sense.
Okay. Now, let's talk a little bit about what does this have to do with trigonometry? Well, I mean, honestly, we haven't done any trigonometry yet, right? We've only just done the Pythagorean theorem, basically over and over and over again, right? But let's relate it to trigonometry, okay? So if we're gonna say theta or x degrees, it's just gonna be whatever the degrees are, right? In this case, it's A. I should say theta, but Desmos has me do A. Okay, so let's say the sine of A, we're going to say the sine of A is equal to, is going to be equal to the opposite over the hypotenuse, right?
Okay.
Now the opposite in this case is always going to be y, isn't it?
Yeah.
So think about it. The opposite's always going to be the up and down, right?
Mm-hmm.
Okay. So it's always going to be y, and then the hypotenuse is 1, isn't it? Since we have the radius of 1, right? No matter what the degrees are, it's always,
yeah.
Okay?
Okay.
So sine of A will always be y. Okay?
Oh, yeah.
Okay? So cosine of A is always going to be adjacent over hypotenuse, or in other words, x over 1. Cosine of A is x.
Yeah.
Okay. All right. So let me just summarize this real quick. Okay. Let's use a different color actually. On the unit circle. Okay. This is obviously just for the unit circle, because once the hypotenuse is no longer 1, it doesn't, then you have to do a conversion ratio. But because the hypotenuse is 1 in the unit circle, then opposite is just sine, adjacent is just cosine, because the hypotenuse is 1. Okay. But it's this is why we use the unit circle to summarize trigonometry, because we have manipulated it to make the radius 1. Okay. Radius we're talking about circles, or the hypotenuse when you're talking about triangles. And we kind of mix them all together here. Okay. So x, y is cosine, cosine, sine. Okay.
Okay.
Now, let's take a look here at 30 degrees, okay? I'm gonna go ahead and change this guy to 30. Let's say we're to look at the 30 degrees, okay? Let's try to figure out the slope of 30 degrees. So the slope of this line right here that's made from the 30 degrees, okay? So we can do slope, right? So we have 0, 0, and root 3 over 2 and 1/2, right? As our 2 points, correct?
Correct. Yep.
Okay, so we're going to do the slope of 30 degrees, right? I don't know exactly how you say it, but just hang out with me here for a second. Okay, so we're going to do 1/2 minus 0 over root 3 over 2 minus 0 is 1/2 over root 3 over 2. Okay, so then this is going to be is 1 over the square root of 3. We're going to convert this is root 3 over 3, which you may remember is the tangent of 30 degrees. Okay, so this is the same thing as the tangent of 30.
Yeah.
So
yeah.
no. So watch this. Okay, so tangent is rise over run, right? Isn't rise just opposite and run just adjacent?
Yeah, opposite
Okay.
and adjacent.
So
tangent is opposite.
Even though the tangent isn't explicitly on the unit circle, it's still there because it's the slope. Okay, so tangent is slope. Okay, so tangent, so slope, I'm sorry, let's write it like this. Okay, so tangent is equal to opposite over adjacent, or in other words, y over x, or in other words, sine over cosine, or in other words, slope.
Rise over run.
Rise over run. Yep, let's put that there too. Let's put them all there, okay?
Mm-hmm.
So tangent of A is equal to opposite over adjacent, or in other words, y over x, which is of course rise over run, which is of course sine over cosine, which is of course slope.
Slope.
Okay? Tangent
Okay.
is slope on the unit circle.
Mm-hmm.
Okay, so a couple more things I want to tell you. This is called quadrant 1. This is called quadrant 2. This is called quadrant 3. And this is called quadrant 4. Okay? Quadrant 1 is positive, positive. I don't know if I want this one is negative, positive. This one is negative, negative. And this one is positive, negative. Make sense?
Yeah, we're doing all the quadrants now, so yeah. Mm-hmm.
Right, exactly. And then the last thing I want to tell you, which I kind of already showed you when I did this guy, is this. Now this is just the, oh no, I did it again. Oh wait, that works. Okay, good, okay. No, it does not. This is incorrect. There we go. Line up the ones, that's what we need to do, right? There we go. Okay. All right. So also one thing you need to remember is that sine squared plus cosine squared, no matter what it is going to be equal to 1 squared. This is the Pythagorean theorem. We don't usually write 1 squared. We usually just write 1. This is called the Pythagorean, this is called a trigonometric identity. So there's a lot of them, but the ones you need to know for right now from the unit circle are going to be this one. You also need to know the sine of A is equal to cosine of 90 minus A. And also the cosine of A is equal to sine of 90 minus A. Okay?
Yeah.
The sine of one angle is equal to the complementary cosine of the complementary angle. And vice versa. Okay, and the other thing you need to know, of course, is tangent is equal to sine over cosine. Those are the trigonometric identities you need to know for the SAT.
Got it.
Okay, so this is a little bit more than you need for the SAT, I'll be honest. But if you didn't, since you were like, I'm iffy on the circle equation, I thought, let's just do this because it's going to help you with all of it. You see how it's related?
Yeah.
Okay. Do you have any questions about this?
No, you went over all of it, so there's nothing really confusing left. And it's also enough information that I could do it for like any problem that involves like the circle trigonometry. So
that's correct. So a lot of teachers will tell you to memorize a unit circle. That's fine. But I don't ever recommend memorizing the unit circle until you can actually build one. Now, do you want to be like, I get a lot of students who memorize unit circle, but they don't understand it. And I get hired a lot in that pre-calculus area, right? So I get a lot of students that get hired when they understand it, but they haven't memorized it, or a lot of students who have memorized it, but they didn't understand it. Both of those, you're limited when you start doing pre-calculus. So for the SAT, you don't necessarily need to memorize this. I would memorize the first quadrant, but as you can see, that's probably not that big of a deal. You could probably just work it out, you know. But if you can understand the first quadrant, the rest of it will just take, how does it work again? Then you can just figure it out. Okay. And if you don't memorize the radians, just remember that conversion ratio. 360 is equal to 2 pi, but most people will just say 180 is equal to pi. But you can do 360 is equal to 2 pi too. Yeah. Okay. Now I want you to take a screenshot of this because you helped me make it. every step of the way. And then I'm also going to share this Desmos link with you so you can play with it as well.
Okay. Could you share like everything on Zoom? Because Zoom is like the most accessible.
I will, yeah, of course. So I'm going to share this recording with you, and then I will share Desmos with you, and I will, did you take a screenshot?
Yeah.
Okay, I'll email it all to you. Okay?
Okay, perfect.
All right, great. Do you have any questions? No,
No, we went over everything that I wanted to know, and this is going to be like the most help for the SAT prep too, because I don't know that much about trigonometry and circles, obviously. So this is like the best.
Great.